Carpe Diem VPN. Seize the network.
Hey everyone, this is Tim from Carpe Diem VPN, and I'm working on a new series of videos here for Viptela Cisco SD-WAN, and I'm not sure of the format. I'm not sure exactly how it's going to go. I'm going to try a few things. I'm going to try to make some really short videos about some basic tasks that we do in the vManage and using the Fabric, and then maybe some common problems that we solve when designing deployments. So I'm working on rebuilding my lab right now, and rather than make videos about building the lab, which there's a ton of videos about that, I'm just going to cover some of the problems or challenges I'm trying to solve while rebuilding the lab. So today, the challenge that I'm solving is that I have rebuilt my T-Rex traffic generator. It's in the branch here and in the data center, and I need to advertise those emulated clients and servers subnets to the rest of the network so that the DC servers can reach the branch, and so the branch emulated clients can reach the emulated DC servers. So looking at the diagram here, we can see that the subnet we're going to use for the clients is right here, is 10.10.100. And the subnet we're going to end up using for the servers, for branch 1 at least, is going to be 10.1.100. Now, these subnets don't actually exist on any of the network gear. They're actually emulated. They're behind the T-Rex itself. And the T-Rex, of course, is not part of this diagram, but it basically sits here, and it has a port pair model where it has an interface there and it has an interface there. And it's going to pump traffic out, both ways really, but let's just say for sake of argument, the idea is that it'll pump traffic this way from emulating a client, which will then flow through the network and ultimately end up here and then be redirected down back towards the T-Rex so that we can get that traffic seen by the SD-WAN Fabric, and also just so we can get some data about performance through the network. So in order to get this subnet 10.10.100 advertised, we don't have any kind of routing protocol on the T-Rex or anything. What we're going to need to do is on this branch switch is create a static route that is pointing at the IP address of the T-Rex. So we'll inject this 10.10.100 route into the network that way, and say that the next hop is the T-Rex itself. Now at the branch, we're running OSPF. So just running OSPF here. At the data center, we're running BGP. And then of course, across the fabric, we are running OMP. Now I've already injected the route into OSPF here at the branch. I've created a static route on the branch switch, and we've got a route for that subnet here on the branch WAN router. So now we need to just figure out how we're going to get this OSPF route into OMP. So here I am logged into both SD-WAN routers, one on the branch side and one on the DC side. The branch router is connected to the branch core. That branch core is where I injected the static route pointing at the T-Rex. And you can see that I then redistributed that route into OSPF. And so it's being learned on the SD-WAN side as an E2 and OSPF external route. On the DC side, you can see that that route is not being learned via OMP. If you haven't seen this before on iOS XE, the M designation refers to OMP routes. So what could be going on? Why are we not learning this route? I can tell you by default that Cisco SD-WAN only redistributes connected, static, and OSPF internal routes into OMP. And because the static route was configured elsewhere and then learned here, so if we configured a static route on branch 1, SD-WAN 1, that would be injected into OMP. But because we're only learning it, and we're learning it as an E2, an external route, that's not being injected into OMP by default. And that's a part of the loop prevention mechanism. So we can jump into vManage and we can fix this. So let's go and jump into vManage now. So here we are logged into the vManage, and of course we only have 4 WAN edges, 2 on the DC side and then 1 on each branch. We have 2 branches. Let's take a look at our templates and just see what we're working with here. The reason we're taking a look at our templates is because in order to change the behavior of OMP, we're going to have to edit that template. So you can see in this case, based on the setup that I built for this lab, each WAN device has its own device template. You can, of course, combine them, but in my case, I had each branch and DC device did something different, so I needed a device template that's different for each one. So let's go over to feature templates. Now, OMP is one of those by default templates that gets issued when you create it. My suggestion, though, is right out of the gate when you are setting up a lab or a production environment to set up and create, even if you just clone the factory default template, create your own OMP template. And let me show you, actually before we jump into it, let me show you why. So here I've got 4 different device templates. So you can imagine, in a global deployment, we may have many more device templates, or maybe, we just are able to minimize the amount of device templates we have. But let me take a look here and show you. So jumping into this device template, now this device template only governs one device. In real life, it might be multiple, it might be hundreds. It's very unlikely, however, to be the entirety of the enterprise. So you can see under this device template, and for the devices that are controlled or managed by this template, if we go back to, say, the factory default template, you can't change anything with this OMP template. So given our use case here, we want to change the behavior of OMP. We can't change the factory default. So that's the first thing, is that if you want to change anything at all, you need your own template. And the second is this. Let's say that I go into this device and I want to, I change something. Now, when I go to push that change, this is the OMP template. OMP decisions, it's a protocol. It's going to affect the entire fabric. So if I've got 5 different device templates, do I want to have to update 5 different device templates differently at different times? Do I want my network to be making different OMP decisions while I'm updating the device templates? Probably not, right? So what you want to do is right off the bat, create yourself a new OMP template. And then even if you change nothing about it, make sure that that's the template you use for all of your fabric devices. Because ultimately, what's going to happen is this. When you want to finally make a change, you want a change like that to affect the entire fabric at the same time. So right here, you can see all of my device templates are using the OMP template. And because of that, I can go into the single OMP template and I can change the behavior of the entire fabric with one push, as opposed to having to go to every device and update it manually, basically, to a new OMP template. So just a suggestion there for either production or for labbing. Any template that's going to affect the whole fabric, you should clone it or copy it and make a custom version of it, and make sure all of your device templates use that custom version so you can push from one template and have an affect all of your device templates. So in this case, let's see what we need to change. So we want OSPF External Routes to be allowed to be redistributed into OMP. So we go to the OMP template because it's the behavior of OMP that we want to change. Sometimes people are confused about, well, which template do I change if I want certain behavior to happen? Like, hey, I want to change that OSPF will be, external will go into the fabric. So they think they have to go to the OSPF template. But you have to think about it like, what is the config I'm trying to change? What is the feature whose behavior I want to change? So here we want to allow OSPF External Routes to be redistributed into OMP and be learned across the fabric. So we will check the box for OSPF External. That's the change we want to make. So let's go ahead, and that's the only change we want to make right now. So let's update this. And what you'll see is that vManage will figure out how many devices and how many device templates are going to be affected by this. So let's see. You can see here, these are the device templates that are affected. And then, so for example, using the branch 1 SD-WAN device template is this one box. In this case, I'm not changing any actual template config. So I'm not changing anything like an IP address or something that would require that I actually enter new values. I'm just changing the behavior of OMP. So that's going to be automatically done. So I go to next. If I want to, I can look at the config difference here. I can see what the preview of the actual CLI that's going to be pushed, and I can see how it's different than what I was already running. So give me a moment here and it will load. And so here's the actual CLI config of the whole box. Let's just focus on where it's going to be different. Scroll down here. And you can see that we're adding, scroll up a little bit. So under OMP, we're adding, under address family IPv4, we're adding advertise OSPF external. That's what we want. Let's configure devices. We're just verifying that we want to make the change in multiple devices. And now we only previewed the config for the branch 1, SD-WAN 1, but that's because we were only looking at that one device template. You have the ability to click through, as I showed you, and kind of choose different device templates and see what other devices are going to be affected. In this case, it's the same config on all those devices, so it wasn't much point in looking at all the other device templates. So we're going to see now that it's going to build the config and it's going to push it to those devices over those control plane tunnels, and then we should see a behavior change. Okay, looks like the push was successful. We can actually go in here and look at the logs, see what happened. Template successfully attached. So it didn't, so it took the config, it didn't have any problems with it. So let's jump right back over to our lab and see if our routing has changed at all. Okay, we're back over here at the lab, and as you can see, we have a new route in the routing table on DC1 SD-WAN 1. That's 10.10.100. That's the OSPF external route. So it wasn't there before. We pushed the change. We're not advertising it. And you can see we're now learning it over OMP. All right, well, I hope this has been helpful. I hope to bring some more videos, tips, tricks, and instructional stuff around Viptela soon, a little shorter than some of my previous stuff, so that you can hopefully just use it and just watch the video that you need for the thing you're trying to do. Thanks for watching.